I think we did this last one, right? Swar, can you hear me?
I don't remember. I don't think we did this.
No. We did this, na? Last one, refraction of light.
Yes, refraction of light.
So yeah, today we have to start from here. So you will write, you will write hashtag. Don't write right now. Let me just explain. Refraction of light follows certain rules. Okay. Or you will write hashtag clause followed by reflection of light. First is, if light travels from rarer medium to denser medium at an angle, it moves towards the normal. So normal, you know, it's basically the perpendicular one. So for example, this is your incident ray, right? If it is moving from denser, the rarer to denser, so it will move towards the normal. Okay, it will move towards here. But if the light travels from denser medium to rarer medium at an angle, it moves away. So if your medium is moving from denser to rarer, then it will move away from the normal, right? It will not move here, it will move away. And if the light travels from one medium to another along the normal, it does not change its position. So if it is moving from a normal medium, it can be anything. So at that time, it doesn't change anything. Clear?
Yes, ma'am.
Okay, so see, the optical density of material is not same as its material density. Okay, optical density of the material is not same because optical density you already know. Optical density is basically the speed. So speed of material is not same because its density is different. Clear? So you will write hashtag reflection of light follows certain rules. First rule, second rule, third rule.
Yes, ma'am. Right. Ma'am, written.
Okay, so now coming to next thing, which is spherical lenses. Okay, there are two types of lenses. One is convex lens and one is concave lens. Okay, so first of all, what are the spherical lenses? So a transparent material bound by one or two spherical surfaces is known as spherical lens. Okay, there are two kinds of lenses that we will study. One is convex and one is concave. Convex looks like this. You will draw the diagram, and concave look like this because it is forming a cave right from here and here. So thicker in the center and thinner at the edge. So at edge it is thinner and thick in between. Thinner in the center and thicker at the edge. Okay. So over here what happens when a beam of parallel light ray strikes the convex lens, the reflected ray converges to a point. So when light is being strike to convex lens, they converge. Converge means come together at a point, right? Therefore, the convex lens is also known as converging lens. Why? Because it's converged all the rays. But when a beam of parallel light rays strike a concave lens, it reflect rays appear to diverge at the point. So see, these are coming and they are diverging. They are not coming together, they are diverging, right? So therefore it is known as diverging lens. Clear? So for one marker also it's important. You will write first hashtag spherical lenses. Then you will write till here. Okay. And after that, types of spherical lenses, convex and concave. You will draw the diagram as well. Okay.
Yes. Ma'am, written.
Okay, Swar. After this, you have to remember these terms which are related to lens. Okay, very, very important. Even you will draw the diagram. Okay, so each lens has two spherical surface. Each of the surface are parts of a whole sphere. So it's a two spheres, like one is this and one is this. So basically these are the terms. First is center of curvature, right? They have two center because it has two spheres, so it has two center of curvature. One is C1 and C2. This is your C1 and this is your C2. Okay. Hmm. Now, radius of so the center of the spherical surface of the lens, as there are two spherical surface, so they have two centers. So this is basically the center. Okay, so this is C1 and this is C2. Then the radius is the spherical surface of the lenses, which is R. Principal, principal axis and imaginary line joining C1 and C2. See, this is the principal axis. Okay, why it is known as principal axis? This one, because it's an imaginary line. It's not actually there, but it's the imaginary line. Okay, this is principal axis. And then next, optical center. So this O, for example, this is your lens. So between this is your optical center, and F, which is focal length, the distance between the principal focus and the optical center. See, optical center, the distance between principal focus, right, and optical center is known as your F. Clear?
Yes, ma'am.
Okay. And you can see this is your convex lens and this is your concave lens. Okay. So remember one thing, principal focus of convex lens and principal focus of concave lens. There's a difference. See, the point at which the ray of light parallel to the principal axis converge after refraction forms a convex lens. So you can see that they are convexing and then they are forming F2. Okay, but in case of concave lens, the point at which the ray of light is parallel to the principal axis appear to diverge. So over here you can see that they are connecting and they are diverging. So they are diverging, but they are not coming here. So that point is basically known as F2. And this is basically the focus point. Okay, principal focus. So principal, everything is same, but the only difference between convex and concave lens is principal focus. Okay, in convex lens, principal focus is basically it converge all the things, and over here principal focus diverge the things. Clear? And remember one thing, for thin lenses the radius of curvature is equal to twice of the focal length. Very, very important. So if you have the lenses, the radius of curvature will be basically twice the focal length. So if it is 4, like if it is 2f, right, it will be double of it. If it is 2, it will be 2 multiplied by this. Clear?
Yes, ma'am.
Okay. So we will write hashtag terms related to lenses. And then each lens has a two spherical surface. Each of the surfaces this first, second, third, fourth, fifth. Then you will draw a diagram. This you will write principal focus of convex lens. And then you will draw this. You will write principal focus of concave lens F1 and F2. Clear?
Ma'am. Ma'am, done.
Okay, you have to write this as well. Okay.
Okay, ma'am. Ma'am, done.
Okay, so now coming to next thing, we have this, the drawing the ray diagram. Okay, very, very important. We usually use ray diagram to study the formation of images of lens, right? So we need to follow certain rules to draw the ray diagram correctly. These are the rules. So write it very like in a very good way. See, incident ray which can be considered while drawing raw diagram for images formed by a convex lens. First, an incident ray parallel to principal axis of a convex lens passes through the principal focus after refraction. See, if your incident ray is parallel to your principal axis, right? Then when it will touch, or it will it will touch this convex lens, it will pass through the principal focus. Clear? And if your incident ray is passing through a focus, it is passing through a focus, then what will happen? It will become parallel. Once it touches this lens, it will become parallel to the principal axis after reflection. Okay. Then after an incident ray passing through the optical, for example, if your incident ray is coming from here, right? So through the optical center of the convex lens emerge without any diversion after it. So basically it will go straight away. It won't divert anywhere. Okay. Clear? So these are the rules. So you will write hashtag
Yes,
drawing
ma'am.
ray diagrams for image formed by lenses. So you will then write this. We can follow this and then first, second, third. You will draw this diagram as well, because sometimes even instead of reading all this, you can just clearly say that, okay, if your incident is parallel, then it will go from F2. If your incident say passes from F1, it will become parallel once it gets refracted. If your incident passes from origin, then it will don't divert, it will go straight up. Okay.
Yes, ma'am. Ma'am, written.
Okay, sir. You also drew the diagram? Swar.
Ma'am, all the three?
Yes, all the three.
I only did one.
No, you have to, because see na, for first rule, this is the diagram. For second rule, this is the diagram. For third, this is the diagram.
Yeah, okay, ma'am. Understood. Understood. Ma'am, done.
Okay, Swar. So now we have next thing, which is incident rays, which are considered the drawing the ray diagram of concave lens. Okay. So see, concave lens, we have three rules. First, an incident ray parallel to the principal axis appears to diverge from the principal focus after refraction. See, this is your incident ray. Once it is diverging, once it is coming in contact of concave lens, it is basically going upward, diverge the principal focus, right? And see, if incident rays which appears to pass through the focus of the concave lens, like it is passing through the focus, right? Like this, then what happens? It becomes parallel to the principal axis, right? Then an incident ray of light passing through the optical center, if it will pass from center, it will go away without any deviation after refraction. Clear? Clear. So,
Yes, ma'am. Ma'am, done.
okay, Swar. So now that's it for today. Okay, tomorrow we'll just do this.